Okay, but if we have these curves, this is just a principle. How do we continue now? So we have this curve, and the nice way of dealing, how most of the standards deal with this, is that you have some kind of fatigue stress limit or a fat class for different materials. The type of direction stress I already explained, so whether it's a weld or not a weld, and whether we have stress concentrations factors. And standards make different approaches to this, but the general idea is always the same. I need to determine some kind of a fat class or a classification of a detail, and then the rest of the curve is fixed. So I have here a couple of examples. This is the British standard. This is DNV GL. You see, for example, here there is no lower limit. The IIW, that is the International Institute of Welding, and the Eurocode is more or less the way as I explained to you. Typical detail for the Eurocode is, I don't know, I can zoom in. If I have here the fatigue stress limit is defined at 2 million load cycles because of past tests and measurements, but the slope change is at 5 million load cycles. And this curve here means that if I have no stress variations below this number, you might consider that infinite fatigue life. But if I have stress variations, a couple of them above and a couple of them below, then I need to continue this curve all the way to 100 million. Yeah, but you see also between the different standards, they all have some kind of classification. In the Eurocode, these classifications have a number, so that is the stress range, so the delta sigma in Newton per square millimeters or in megapascals. That's the same thing. Yeah, and you see that in the IIW also same classification. In the DNV, of course, I always say that DNV does things different just because they want to be different. They do not use these fat classes with these numbers, but they have classifications. They have B1, B2, C, C1, C2, and so on. So they have some kind of naming in these classifications. And the BS has something similar. Yeah. So although we have different standards, the idea of these curves is always the same. And so the method with Palmgren minor and fatigue summation is also always the same. Okay, now do I get to the next sheet? Yeah. Okay. Then the first question is, okay, it seems to be apparent that this fat class is the most important. So how do I determine this fat class? And is there maybe first, if there is no weld, maybe is there a relation with yield stress? That is a logical question, no? Turns out to be this is a curve for steel of different types with different yield limits. So I have fat classes, the endurance limits here in number in PSI. Yeah, it is an American graph. But the most important things, I transferred these into megapascal. So if I have a fully polished plate, then I can follow this rule so that the stress variation is more or less half the ultimate stress limit. Yeah, so that is the number, that is the ultimate stress. So that is not yield, but the ultimate stress limit at break. Yeah, and then you can see there is a difference between polished plates, standard ones, and corroded, for example. And you see that these curves changes. So this simple rule of thumb, okay, depending on my yield limit I have, if I use better grade material, I also have a better resistance as fatigue. That is only true if your surface of your plate is of a certain quality. How does that translate in standards? I'm a big fan of the 13001. That is the crane standard, and the advantage of this standard is that it is very, very specific. I hope the Eurocode will come with an update which is as specific as this code. But here you can clearly see that if I have a material with a yield limit, I can see that depending, if I increase my yield limit, the fatigue class increases up to 280. So that is a third of the yield limit. Yeah, and here, just to go back for it, this is the ultimate, that's not the yield. So half of the ultimate is around a third of your of yield. So you see, okay, this effect of better material quality is there. So for standard mild steel is with yield limits, so let's say 220, this is the standard, that is standard 180. And then we have something here which we call the edge quality and the surface condition. So if the surface condition, the surface condition is the variation is less than 20 micrometers, then that is considered very polished. Then I have this curve. And if I have more coarse, or for example, if I have a plate which I do not laser cut, but I do that so just thermal cutting, then I always have a lower grade limit of 140. Yeah, so the surface quality is important as well, as you can see the standard. If the surface, so if the surface conditions gets to more standard, I get lower limits. Yeah, so if I want, or put it the other way around, if I want to take into account the higher fatigue resistance of non-welded steel types, I need to make sure that my surface quality is under control as well. Yeah, because I can use for yields of 900, but let's say S690, so that is then this one. I can use a fatigue limit of 250 if my plate is nice. If the plate surface condition is according to this standard, and then less, the variation is less than 20 micrometers. Yeah, and if you do not control that you end up with the same limit as normal steel, slightly more. It's 180, while 60 is mild steel. So S355, which is this one, S355, that is this one. Oh, yeah, this is more or less the normal condition. So in general, you use 160 for S235 and 180 for S355. But that depends on the surface condition. If you do not take that into account, or your edge or your cutting limit is not okay, you might even end up with a very low fatigue limit. Yeah, so take that into account. And this is, yeah, this is basically the quality of the manufacturer.